Okay, today we got partition array into two arrays to minimize some difference. So we have a length of 2n, two arrays, minimize absolute difference of the sums. To partition nums, put each element of nums into one of the arrays, minimum possible absolute difference. There's 15 of them. Oh, okay. So n is 15. I think I just did a similar problem which required meet in the middle. I think this will require meet in the middle too. But I don't remember what it was, dude. Top half and bottom half, and how do I combine them? I know. So we calculate subset sum for each so we pick first half of elements and second half of elements, and we keep their difference. And then for each possible difference, like when, let's say the diff would be like 10, so like diff is equal to I don't know, left, so let's call them left and right subarray. So we have diff is sum in left minus sum in right, and then what we want is, we've got some of them in the other array, and if we could find closest number in to minus diff, that's what we need to do. So let's compute, let's see. Oh, they also want, what can the difference be? Well, if I know the diff and I know the other diff, yeah, okay, so that's what we need. So we need like a set of first half compute subset diffs let's call this set first subset diffs, subset diffs of first half. Let's do this. Noise begin. So now what we do, well, we compute the sets of differences. So subset array. So first we compute the sum. Sum can be 3 times 10 to 8, so it fits. So this is what we do, and then from 0, and then we go through mask resulting set, we go through all subsets. Let's see what MD arrays has. Or let it be M in this case. Let's call this bit. If mask shifted by bit and 1 it's in that subset, so current sum plus equals nums of bit, and then res set insert, and that's, so let's say left subset is cur sum and right subset is sum minus current sum. So now we have computed subset sums for each half, and now we are interested in the result. Well, sum of it. So what can be the maximum answer? Well, if sum of half of, well, sum of 15 elements can be at most 1.5 times 10 to 8, and sum of other elements, so we can get just their sum in total, I guess. So we can get max answer 1 in 9 will be safe. So 4 int sum in set first, or let's call it if, and now we do auto iterator, lower bound, set second begin, set second end, and then minus if, and what now? So we found the closest one, that is, or let's do upper bound. So we find the first largest one. Yeah, that's fair. So if it doesn't equal set second end, then answer, well, if we have the diff is 1 in here, and then it's what, this plus this is minus 5, so minus 3 in here, so this has, let's say we partition this such that it has So they have diff of this in here, and then they have diff of this in. So let's say we have diff 2 here and then diff minus 10 here. And how do we combine it? Well, that's minus 8, I guess. So answer is mean answer and then diff plus iterator, I guess. And then if it doesn't equal set second begin, then it's previous it. And we don't even need to do that. Answer is mean of answer and diff plus, and then we return answer. Nums, no, we got array, but that's fine. It's fine. So maybe it should be minus that. I probably should not be guessing. Let's see. See. Well, that's weird. So I can have a delta of this. So if I take delta of 12 here, let's see. Well, if you partition it differently, let's see. I don't understand this a little bit. So I search for well, if I split them into 36 and minus 36, I get 72, and if I split them like this, I get it's a negative 36, and then 36 is the difference. The first one has a diff of what? So first one has a diff of well, let's say we put minus 36 into the first one and nothing into the other one, so the diff is minus 36, right? So we got a nothing, so we got a minus 36 and nothing, which is equal to minus 36, the difference, right? So that should be right. So that's current sum, total sum minus current sum, that's like 0, so minus 36, yeah. And in the other set, let's say we put we need to put at least 1 in both of them. Now it should work. No. So what I cannot combine is, so let's also store the mask, right? And now when we do this, we check the upper bound. Let's call it original position of the iterator, and then we do like iterator is original iterator, and now we do while iterator doesn't equal end. And what happens is that make pair, fair enough, and what needs to happen is that we cannot have auto diff and mask and well, if they all would be the same, so either all zeros or all ones, so everything is put into one basket. So and or like that, I guess it's fair. It's okay, so I don't know, let's call this flag. So if no, it shouldn't be flag. No, let it be just mask. So what we want to do, if mask is 0 and then mask is 0 and it or also 2 ones. How do I know that? Built-in pop count of mask is equal to first half size and built-in pop count of it second is equal to second half size. This is the most disgusting garbage of all time, but who cares? So if this happens, built-in pop count. Nice. Built-in, 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 built-in. Did you mean I cannot type? If not all that, break, otherwise it's next, it's because here should be first. I'm outputting way too much stuff. it's gonna TLE. No, it's gonna wrong answer. That's awesome. So maybe I can do this. And okay, that simplifies it a little bit. I don't have a print function for mask. There is what, 15 of them. So right here, this is my 2. Here, this one. So 1919 you say. So if the this is 1 1 0 and 0 1 and zeros. So from this half for these to go into one group and these to go into the other group. So you get what, 65 minus 84 is minus 19, right? For 1 1 19 for 1 1, really? Okay, yeah, okay, 19, and then this other half you put 84 here, and then you got 84 minus 103, that's minus 19. So then I got to be stupid. Let's see. I'm gonna use the calculator real quick. So in one we put 45 and 20. No, we put 76 plus 8 and then 84, and then in the other half we put 45 minus 20 minus 74 minus 28 minus 1. So that should work, I guess. Partition nums, put each element of nums into one of the two arrays. I don't understand what did I do wrong? Like, you have 76. I can literally just 76 plus 8 plus 84, right? And then we do minus 45 plus 20 plus 74 plus 28 plus 1. Let's see. 0. I just partitioned them with difference 0. What? Oh my days, they're like, oh my god, bro, what the fuck? Equal length is stupid, extremely. So let's see, result set in, let's call it the result set, and now count, insert, insert that in there, and then let's return map this. Fair enough. So we go through for something. So instead of going through it like this, for auto, this will be count. And then this will be the ifs overset first, and then we go for auto diff in ifs, and we run this code. So if set second count of n minus count. So if it does not have that, we continue, great. And then what we do, well, in n minus count, and we'll look for negative if. We can skip this, and then we just check this. Boom, erase this. Boom, 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 boom. This looks bad. Don't understand one thing though. fair. And then that's weird. That is indeed weird. Res set of count. How is that possible? Okay, so that's the I think this should work. Okay, let's see. This print can be erased. It's slow, but this and this, and maybe that will speed it up. I don't know. TLE. That sucks. Let's go to the vector. And sphere. So let's have like a vector and then pair ingress set sort back maybe, so maybe this will work. Okay, that worked way faster. Great. So it's slow, but whatever. Okay, that's disgustingly slow. Meet in the middle. So calculate all n is too large to calculate all subsets of length n divided by 2. So instead, if we split the array into two halves, can we combine the differences of arrays, differences of partitions in the halves, in each half, for first and let's compute all possible partition differences for first and second half of nums. Now let's iterate over all diffs from first half and find closest diff from the second, all diffs diff from first half and find closest diff from the second half to minus diff, since we want their differences okay, so let's go partition differences for first and second half of nums. That help us, well, to know the difference, the total difference, to know the difference of the entire partition, we just have to sum the differences of both partitions. We can achieve that by iterating over and finding the closest diff from the second half to, since we want their differences to be closest their sum to be as close to 0 as possible. We can do this with binary search on the differences. Note that we can only combine two partitions if they partition the original nums into two subsequences with equal length. To do that, when calculating we keep the differences grouped by the count of elements in the first partition. Then when iterating over differences in group group and we differences when iterating over the first half differences in group count. We only check the differences in a group and divided by minus count. Check the differences, only check the second half differences in group, so that the combined partition has equal lengths time complexity. Well, we first calculate this grep, which is 2 times n half, and then 2 times n half we do sorting. First we generate all differences for all subsets of each half, which is O of 2 and divided by 2, and then we sort them, which is O of 2 and divided by 2 log. Well, log of this, isn't that like n half? So which is equal to O of n like that, I think. Okay, and then finally we iterate over all differences in first half and binary search over the second half differences, of which there are O of 2.5 and binary search of which there are also 2.5, giving us the final time complexity of the search as the total of the search n c dot 2.5, which is also the final time complexity. Space complexity is O of 2.5, since we store differences for all possible, for all O2 to the n-half partitions. Great, so something like that. That's alright, whatever. I don't know if anyone will be able to understand this, so okay, meet in the middle. Okay. Okay, I figured it out. Who cares? Goodbye.